right, ladies and gentlemen, lesson 20. I'd like for you to open your spiral, and I'd like for you to make it look like this. So you're going to have lesson 20 on the right side, and your multiples and this kind of stuff. And then I'd like for you to leave that left side blank so we can glue in some more notes. So here's an overview. Let's get started. All right. Lesson 20 is all about multiples. First of all, what is a multiple? Yeah, it's right in the word. Multiples, right here. This is not only a multiplication chart, but it is a multiples chart as well. And what do I mean by that? I don't know. Here's my original numbers. And here's all the multiples of them. What do multiples mean? 1 times 1 is 1. 1 times 2 times 3. 2 times 1 is 2. 2 times 2. 2 times 3. Multiples. More and more and more of them. 3 2s, 4 2s, 5 2s, 6 2s, 7 2s, 8 2s. More and more and more and more and more multiplying. Multiples. More and more and more. Another thing you can say is you can just count by the number 5, 10, 15, 20 because that's 1 5, 2 5s, 3 5s, 4 5s, 6 5 5s, 6 5s, 7 5s. All right, everyone cool with what multiples are? Your multiplication chart is a list of the multiples of 1 through 12 in this case. All right? But you can do 13. List the multiples of 13. 13, 2 13s is 26, 3 13s is 39, and then you could keep going, boop, boop, boop. You can make a list of 14, list of 15. Is everyone cool with multiples, what they are? Good. So if I asked you to find what is the least common multiple, you can use this list. What's the least common multiple between 4 and 9? The least common multiple. They have all these. 9 has all these. What's the smallest multiple? Least. This time we're looking for the smallest multiple that they have in common. Well, here's a 36, and here is also a 36. Do they have anything smaller in common? Nope, no 27s. So the smallest common multiple of 4 and 9 is 36. Smallest common multiple between 2 and 3? What do they have in common? Oh, 6. All right, any questions? Some of them are different. It's a common multiple between. Anyway, so that's one way to do it, except now that you're in the next grade level of math, the numbers aren't going to be so easy. Look, 18 and 81, they're not on our list. Do you want to make a list of the multiples of 18? Me neither. 81? Me neither. So we need a backup plan. So make a list if they're small, and then find what they have in common. Or, here's plan 2. Plan B. You can, just like we did on our greatest common factor. Does this remind you of anything? You can build a cake. You can write down all the primes they have in common. Look at my M right there. I ran my M's together, sorry. Anyway, find all the primes they have in common, which reminds me of GCF. And then, we're not finding GCF, we're finding least common multiples. They're bigger. Not what divides evenly into, those are smaller. We're finding something that's even bigger than the 3 original numbers or 2 original numbers. So, you write down all the primes they have in common, and we're going to have to write down all the ones they don't have in common, multiply them together for a big, huge number. Let's give it a try. So, everything's the same up till this little new part right here. And then we'll multiply answers together. Let's build a cake for 18 and 81. 2 and 9, 3 and 3. 81 is not divisible by 2, but 8 plus 1 is 9. And isn't the sum of the digits divisible by 3, then 3 goes into the whole thing? Yes. 3 goes into 81, and it goes in, I guess I could do it right here, silly me. 3 times 2 for 6, 21, 7. Yes, 3 goes into 81 27 times. 3 goes in there 9 times. And 3 goes in there 3 times. Cool. So 81 is a bunch of prime number 3s, and 18 is a 2 and 2 3s. So what they want us to do is write down have in common? Well, they both have a 3. That's it. Oh, wait. And they both have another 3. So I wrote down everything they have in common. Check. Now I have to write down everything they don't have in common. They both have a 3 in common. That's this one. They both have another 3 in common. That's this one. Remember, just write it down once, what they have in common. But what do they not have in common? This one has a 2 that this one doesn't. And this one has 2 extra 3s that this one doesn't. So you have to write down every single thing they don't have in common. What they do have in common reminds me of GCF. What they don't have in common is the extra step to help us find the LCM. And then what does step 3 say? Multiply them all together. 3 times 3 is 9. 3 times 3 is 9. And then times this 2. Do you guys want to do 81 times 2? Or 18 times 9? 72. These numbers are going to get big. 72 carries 7, 162. Let me make sure. 72 carries 7, 162. The LCM of this is 162. 18 times something equals 162, and 81 times something equals 162. They can both be... Why would we need to find the LCM of those two big numbers? Okay, let me give you an example. Here we go. What if I wanted to add 1/18 to 181? I'm adding some fractions. And I need a what? Yeah, a common denominator. 18 times what and 81 times what? I have no... Yes, I do. It's 162. 81 times 2 is 162. And 18 times... What do you guys think? 60, 80, 100, 20, 40, 60. Maybe 7 or 8. We'd have to try it out. And we can multiply top and bottom times that. Yeah, we need the LCM sometimes to help us find GCF. I mean, strike that. We need the LCM sometimes to help us find a common denominator of big numbers. All right, let's try one more. And don't forget right here, this little guy over here tells us the same exact thing. This right here, let me zoom in. It's just another way to look at the same exact thing. Find the LCM of these larger numbers. We line up the prime factors. They line theirs up. And see, 18 has 2, 3, and 3. 24's prime factors are 2, 2, 2, and a 3. And see, they have these in common, so they write it down once. They have these in common, so they write it down once. And then they have to write down everything else that they don't have in common. So this LCM is 72. So this is, if you don't like my method, this is another method that might help you. That's why I wanted you to glue it in your notes. Cool, so let's try that last one. It's just a little time consuming, but it's not terrible. This time they want us to find the LCM of everything in these parentheses. 24, 55, and 81. 24, 55, and 81. Give it a try. We'll see in class how you do.